Hello everyone. This is lesson 8 where we're going to see how to solve linear equations. So a linear equation, let me just give you a simple example first. If we say x plus 3 equals 7, then to determine solution we'll have an algebraic way, but we could just intuitively say that x must equal 4. And this would be because, or I'll just abbreviate that as cos, if we replace 4 in this equation for x, then we have 4 plus 3 equals 7, and that of course is a true statement. 7 is equal to 7. So that's if you have a true statement. Upon substituting the proposed solution, then the value of x is a solution, and if you get a false statement, then the value of x is not a solution. So you could read through the example. It was false, so that value is not a solution. In the pencil problem, I'll recopy. 3x minus 7 equals negative 25. Okay, we'll make a substitution or replacement, and note our proposed solution is x equals negative 6, so replace the x by negative 6 as we've done in the past. Remember, put parentheses around the value that we are substituting, and I'm going to do this. I'm going to put a little question mark above the equals because I don't know if this is true or false yet, and then we'll just simplify the left-hand side. So 3 times negative 6, negative 18, recopy, minus 7, is that equal to, I don't know yet, negative 25, and yes, minus 18 minus 7 is negative 25, which equals negative 25, so that's a true statement, which implies that x equals negative 6 is a solution. Okay, so we want to know how to go about solving this equation without being given the proposed value. The first property is the property of equality. We saw that before, back with the Pythagorean theorem. You can add or subtract any number you want to both sides of an equation to obtain an equivalent equation. So you could read through the example down to the pencil problem. I'll recopy. Minus 9 equals x plus 7. The idea is to solve for the variable, or the letter. Sometimes students are more comfortable when the variable is on the left-hand side, as in this example. But you have to be versatile. If it's on the right-hand side, just leave it there. And the idea is you want to isolate it. You want to solve for x in this case. So this plus 7 that's being added to this x on the right-hand side of the equation here has to be undone. And to undo a positive 7, we're just going to subtract 7. Now, I feel the most efficient way is to show it as I'm showing it here, where I'm showing subtract 7 from this side, line up the equal sign, and whatever we do to one side of the equation, we have to do to the other. Then I'm going to show the addition bar, do the arithmetic. Minus 9 combined with minus 7 gives minus 16. Bring down the equals, bring down this x, and these go away. There's no need to write a plus 0. So there's our solution, x equals negative 16. Then we have the multiplication property of equality, which basically we've used before when we solved proportions. We really used it in the form of a division. So the rule is basically that you could divide both sides of an equation by any number you want to obtain an equivalent equation, and multiply as well. So It's sometimes cumbersome to think of multiplication in terms of the reciprocal. So you could read this over. The easiest way is to think of this alternative approach. We're just simply going to divide by the coefficient of the variable. So to the pencil problem, I'll recopy. If I have minus 7m equals minus 63, we note that the minus 7 is being multiplied by m, so to undo the multiplication, we can divide. I'm going to show an extra step here where I'm dividing by the coefficient, sign included. Never the variable, you're only dividing by the coefficient of the variable, or as you may say, the number in front of the letter, but the sign included. And then if I divide this left side by 7 to keep everything balanced, the negative 63 needs to be divided by negative 7 as well. The negative 7's cancel, formally replaced by 1's. We get 1m over 1, or 1m, or just simply m is equal to, and then we do the arithmetic, and negative 63 divided by a negative 7 is positive 9. I should mention you could be showing the check every time if you like. If you trust in your algebra skills, then you don't need to formally perform the check, but that is making the substitution and making sure we get a true statement. If we have rational or fractional coefficients, that's where the idea of the reciprocal may be valuable. But I actually have a little trick for you. You could read through the example where the coefficient was 3/5 and we multiplied by its reciprocal 5/3 to obtain the solution. But here's a little trick, and I'll show you this for this problem, this example, and then for the pencil problem as well. So if you consider this 3/5 x equaling 12, instead of writing the x following the fraction, let the x be absorbed into the numerator of the fraction. Write it as 3x over 5. And you can also, if this number on the right-hand side in this case is not a whole number, it would be a fraction. But if it is a whole number, as we have here, write it as a fraction by writing it over 1. And the reason why I'm suggesting this method is because everybody's used to cross multiplication. Because now at this point, we could just simply cross multiply. We get 3x equals 5 times 12 is 60. And now we can divide. So 3x divided by 3, 60 divided by 3, and we get x equals 20. So I feel that's an easier way to proceed. You could proceed any way you like, but that's what I'm going to show in this pencil problem. I'll rewrite the way it's given. Once again, fractional coefficient, you could use the idea of the reciprocal or this proportion approach. So I'm going to write it as negative 2y over 9 as a single fraction, equaling, and then I'll make this a fraction by writing it as 14 over 1. And now just cross multiplication, so 1 times negative 2y is negative 2y. 9 times 14, use your calculator if you need to. That's 90 and 36 is 126, I believe. And now to solve for y, we can divide by the coefficient. I'm going to show that literally in an extra step. Remember, when you do this division, you only divide by the number in front of the letter, the coefficient of the variable. Never put the variable down here because that's what you're solving for. And do the same thing to the right side. And this just ends up giving us y equals, do the arithmetic, negative 63. As I've said in, so there it is. As I've said before, from this step to this step, Most people will just skip this extra step that I wrote here, and when they have negative 2y equals this 126, they'll just instinctively just jump in there and write divided by negative 2 divided by negative 2. If you're comfortable with that, and then you go, of course, to the final answer. If you're comfortable with that, that's fine. It just means you're becoming proficient. Okay, on to the next concept, combining the two ideas, the addition and multiplication properties. The multiplication property, or division property, you could think of it as. Addition is the opposite of subtraction, of course. Multiplication property is the last step. First, the addition property to isolate the variable, and then the division. So notice in this example, just talk through it quickly. We isolated 6x by subtracting 9, and then we did the division. And again, the check optional. So I'll recopy, minus 3, there's the way I make my z's again, minus 8 equals 16. Okay, so you want to isolate the variable first. So this negative 8 has to be undone by adding the opposite, or plus 8. Line up the equals, show plus 8 to the right side as well. The addition bar, these negative 8's go away. There's no need to write a plus 0, and there's no need to bring the negative 3z straight down. You could bring it down here and tuck it right next to the equal sign. Tuck it in there. And then 16 plus 8 is 24. And now it's division. So it's really just a two-step process. So now I divide by negative 3. Divide the right-hand side by negative 3 as well. And z is negative 8. And again, the check is optional. So moving on to the next key concept. So when the variable's on both sides, it's your choice. You could bring the variable to the left or the variable to the right. I'm going to suggest that you read through the example and notice the difference between the two methods. Basically, people choose to bring the variable to the side where the coefficient is greater, so you can avoid negative signs. As in the example, bringing the variable to the right-hand side avoided negative signs in front of the coefficient, but bringing it to the left-hand side, the variable, that is, you had a negative sign, but you come up with the same answer. Y equals 2, 2 equals y means the same thing. So it's your choice. I know most students are comfortable bringing the variable to the left-hand side, but you may want to practice the idea of the right-hand side when the coefficient is greater. Here the coefficient of the x's is greater on the left, so always move the variable first. So we're going to line up the equals. I want to get rid of negative 5x, I want to get rid of 5x by undoing it, adding the opposite, or subtract 5x. Note that I lined it up, the negative 5x right underneath the 5x, and I'm going to line up the negative 5x underneath the 8x. Those are like terms. Here's my addition bar. 8x minus 5x is 3x. Bring down the negative 3, line up the equals. These are gone, that's why we did it. And bring the negative 24 down and tuck it right in there next to the equal sign. And notice now that we have an equation that is very similar to the equation that we saw in the last example, where now the variable's on the left, we'll bring the numbers to the right. Getting rid of negative 3, we'll add the opposite, or add 3. Show it literally. Bring down the 3x. Line up the equals. Negative 24 plus 3 is negative 21. And now finally a division. So divide by 3. divided by 3, and x is negative 7. Okay, so you'll notice that these are kind of like funnels, the way they work, the way the solution looks. I suggest you practice showing your work and doing only one step at a time. The worst thing we should see, and you could read through this example, before we start juggling the terms, which is formally called a transposition, before we start this, the worst case scenario should be that we have ax plus b equals cx plus d, for example. That is, variable and a constant equal to a variable and a constant. Or as you guys might say, letter and number equals letter and number. If there's more than two terms on either side of our little barrier, the equal sign here, we're going to have to combine like terms first. So I'm going to recopy the given problem, 5x minus 12 plus 11 equals negative 7x minus 9 plus 2 plus 14x. Okay, here's the barrier, that's the equal sign. You can see there's more than two things on the left. There's no other x's, so I'll recopy the 5x. But if I combine a negative 12 and a positive 11, I get negative 1. I'm going to bring down the equals and look at the right-hand side. I do see that there's more than two things. I want to combine the x's first. There's negative 7x, a positive 14x, combining to give a positive 7x. And then there's a negative 9 and a positive 2 that combine to give negative 7. Now, here's a case where the coefficient is now greater on the right-hand side. So I think I'm going to choose to solve by moving the variables to the right, because again, you should be versatile. So I'm going to subtract 5x from both sides, line up the equals, line up the like terms, bring down the negative 1, these are gone, bring down the equals, 7x minus 5x is 2x, bring down the negative 7, and now it's a two-step problem. So add the 7 to both sides, and we have 8 equals 2x, and then finally divide by 2. Okay, so again I'm showing it literally, and we get that 4 equals x, which is the same as saying x equals 4. And if you want for fun, you could practice that one, bring the variable to the left-hand side, and you should, of course, get the same answer. Okay, next thing, distributive property. So we've seen the distributive property before. Remember formally, A multiplied by B plus C, distributing the A gives us A times B plus A times C. If you ever see parentheses in a problem, remove them first by the distributive property. So you could read through the example. So what happens is these problems just become a little bit more complicated as we progress. But if you take one step at a time, they're very easy and very systematic. Okay, so there I've copied down the problem. So there is a little lag time in the video here. Okay, and to begin then, we see some parentheses, so let's get rid of them. Let's recopy everything else. 7x plus 14 equals, the 4 is distributed, times x gives 4x. and multiplied by -7 gives -28. The closure of the parentheses here stops the distribution, so therefore just don't forget to add on the +9. Okay, on the left we're good, only two terms, x's and numbers that can't be combined, but on the right we see the constants can be combined. So I'm recopying the left, recopy the 4x, combine -28 and +9 to give -19. And now the coefficient of x is greater on the left, so I'm going to move the variables to the left by subtracting 4x from both sides. If you could do these things mentally, that's great, but I suggest when you're first learning this, write out all the steps neatly. Okay, once you got the variable to the left and isolated, and that's your two-step problem. So just isolate the variable, subtract 14 in this case. Those go away, I'll bring down the 3x, tuck it right in next to the -33 in this case, and finally divide. So go down here, show the division. Many of you are just going to jump right in there and do the division, but I'll show it in a separate step, and we get x equals -11. Okay, so then one more pencil problem in the example, and it's just combination of steps again, including the distributive property. You can read through the example on your own. And here I will recopy the pencil problem. So 9 in parentheses 2y minus 3 equals 5 in parentheses y minus 4, and then close the parentheses +7. Okay, so we see parentheses, distributive property, the 9 gets distributed to the 2y, multiplication, 18y, 9 times -3, -27. Remember, the formal name for the distributive property is the distributive property of multiplication over addition. So that's why, of course, we're multiplying. Okay, distribute the 5. The equal sign is our barrier. We get 5y minus 20. Closure of the parentheses stops the distribution. Don't forget to recopy the +7. Okay, before I start my transposition, notice on the left we're fine, just two terms, letters and numbers, variables and constants, but on the right we can combine. So on the left I'll recopy 18y minus 27 equals, on the right, 5y, and recopying -20 and 7, get -13. Okay, variable first, I'll bring the variable to the left by subtracting 5y. 13y minus 27 equals -13 then. And we'll add 27 to both sides, so it's our two-step problem at this point. So 13y equals, looks like 14, and then our division. Now this one doesn't come out pretty, and that's okay. It is okay to have fractions as your answers. So here we get 14 over 13, and we just leave it. So fractional answers are okay. Now, obviously, substituting in 14 over 13 to show a check would be fairly tedious, but it can be done. Okay, so that's the end of lesson 8 for the pencil problem.